This video is about organic functional groups. I'm going to go through them in a chart, but first we got to know what they are. So hydrocarbons, remember anything that has hydrogen and carbon in it, are relatively unreactive. Other than combustion reactions, which we've covered, where they react with oxygen, right, to combust and make carbon dioxide and water. For an organic molecule to react, so these hydrocarbons, they need something additional. So a functional group or a site of reactivity, that's what our functional group is. They determine the chemistry of a molecule. So a site of reactivity is what we call a functional group. All right, so that really determines how a molecule will behave or react. The simplest function groups are when you have a double bond or a triple bond. Other ones contain other elements other than C or H. Lots of times oxygen is a part of it. So when we're talking about these just in general format, not in a specific molecule, we use R, R prime, or R double prime to represent different alkyl or different carbon groups. So R really is any carbon chain or any length carbon chain. It could be 1 carbon, it could be 15. Okay, so here's the table, and you have this in your notes, that goes through all of the different classes and then the functional group in that class. So class is the name of all the molecules that have that functional group. The functional group is the name of the structure itself. So you can see alkanes, we've talked about alkenes, alkynes, and they are technically functional groups, right? When you're changing from all single bonds to having any number of double or triple bonds. So you can see we also have the suffix, so how the name changes at the ending, right? Suffix is at the end, and an example for each and a general formula. So alcohols are our first kind of new one. An alcohol is when you have a hydroxyl group. Remember hydroxide from our polyatomic ions? It's when you have hydroxide. We call it hydroxyl when it's bonded to something else like this, attached to one of your carbons. Your name changes. Instead of being ethane like this, C2H6, it changes to ethanol. So that ending changes there, and you can see your general formula changes. And your hydroxyl group could be on any carbon, which then you would indicate which carbon it's on. Ethers are next. Ethers are when you have an oxygen in between two different carbons, and it could be anywhere in a chain of carbon. It could be between 1 and 2. It could be between, 7 and 8. So that's called an ether. The way you name an ether is like here we have ethane, but here you have to name how many carbons you have on either side. So here's my ether. So the first is I do my lesser carbons. So 1 carbon is meth. So meth, and then just indicate that it's an ether. We write oxy. You can see methoxy, and then I write down what my other side carbon length chain is, which is 2, so it's ethane. So methoxyethane. All right, aldehydes and ketones, they have 2 different names, but if you notice, they're the same functional group. They're both what we call a carbonyl. A carbonyl is carbon double bonded to O. So what you can see here is if this carbon is double bonded to O and it has an H here, this would be on the end of a chain. Okay, so I'm going to write end carbon. Whereas a ketone is when you have that carbonyl, you still have that C double bonded to O, but you can see it has other carbons on either side. So this is a middle carbon. Okay, and so you can see the names change appropriately. Propanal versus propanone. So ketone ends in -one. That's how I remember the difference. All right, a carboxylic acid is, the whole class is carboxylic acids, but it has a carboxyl group. And a carboxyl group is when you have a carbonyl, what we just did, the C double bond to O, with a hydroxyl. So you can see the carbonyl, right, is this carbon double bond to O, and the hydroxyl is the OH. All right, and this would always have to be on an N carbon because you can see carbon has 3 bonds, right here, 3 bonds in this, so it only has 1 to another carbon. All right, So you can see the ending changes to anoic acid. So if I have 3 carbons, this COOH, propanoic acid. One that's come up before that maybe you didn't realize is we've talked about, I'm going to go on a different page. We've talked about acetic acid and how, right, acids have hydrogen. So this is your hydrogen plus acetate, which is CH3COO with a -1. So this is CH3COOH. Another name for this is ethanoic acid. Eth, because there's 2 carbons. Anoic acid, because here you have your carboxylic acid, your C double bond to O to OH. Then you also have that other C. Okay, IB prefers this name. Okay, other ones, let's see. An ester. So an ester is a combination of carbonyl again, which is this right here. But this time, it's with an ether. So remember, if we go back up, an ether was when you had an O in between carbons. So here's your ether right here. You've got your O, here's 1 carbon, and the other could have any number of carbons on that chain. So that would be where you, again, have to name, remember, because the ethers, you've got carbons on either side of your functional group. So here we do our smallest first. So this is methyl. And then here we have 3 carbons right here. So prop, and then we change it to NO8. So propanoate. All right, amides and amines. So I'm actually going to go to amines first. Amines are when you have a nitrogen with 2 hydrogens attached to it. A carboxamide, okay, has, again, a carbonyl group, which is, right, this C double bond to O, and then you have your amine, right here. All right, so the last couple, so a nitrile is when you have like a cyanide right here, C double bond to N. And an arene is when you have that benzene ring, right? So we've talked about, like, if we just have benzene, if that's the main thing, we could have, like, you know, methylbenzene, where you have like an R, some carbon chain here. When this is the attachment to a longer chain, this is phenyl. This is a phenyl group. Okay, so these are the functional groups. So you need to be able to recognize them in a molecule, whether it's recognizing them in a drawn out structure like this, or recognizing them, like, I should actually look at these, like in these examples where you can see COO versus COOH, okay? The difference between all of those. So there are flashcards in Quizlet in Schoology. Make sure you are practicing these.